Alright, good morning guys. Well, it's probably not morning for you when you're watching this, but we're going to jump in to 2 more lessons for financial algebra, and I'm going to start today with 1.3. So 1.3 in the book is titled Entertainment Expenses, but what it covers mathematically is measures of dispersion. Now what that means is it's looking at data and dispersion. Think of dispersion as how spread out the data is. So when you see dispersion, that's how spread out the data is. Okay? So if we're looking at the heights of people, if we're looking at how much, there's so many things we could measure, the amount of money we spend, the average cable bill. Yeah. So I'm going to go over some of this is review for you. So here are the measures of dispersion. There are 1, 2, 3, 4, 5 that we're going over today. And so I'm going to start with the review items. There is mean. Right? We know that is the average. It's simply the sum of your data divided by n. Okay? And also, it has a symbol. So I'm going to go over that the symbol for mean is X with a line above it. So if you see that symbol, you know it's referring to mean. Okay? Now there is the next one that should be reviewed, maybe not, is range. The range is your highest number minus the lowest number. Real simple. So far we have mean, range. Another one that they cover, and so the next 3 are probably not review. So the first would be mean deviation. So you have 2 words here. Mean would be average. Deviation is how far something is away from something else. So mean deviation is the average of how far each number is from the mean. And the symbol would be X minus X with the line above it. And then here they put the I for index. And they're just saying like the first value of X minus the mean, the second value of X minus the mean, the third value of X minus the mean, and so forth. So here's mean deviation. There is no symbol for range. Mean would look like this. The next one is variance. Now, variance is the average of the square of your mean deviations. And so it's a very long formula, and we're going to do it by hand today because I don't know if any of you have a calculator. So I'm going to show you how to do it by hand. If you get a calculator, maybe we can go over that later. So variance would be this little, it's the omega symbol, but it's the O with a line. Almost looks like it has a backwards cap on, squared. And so it's the sum of your mean deviation, so X minus the mean squared, divided by n, which would be how much data you have. And again, we're going to be doing this, and we're going to be working on this together, and we will do it by hand, so brace yourself because it is a long formula. And last is standard deviation. Now, a lot of times I'm just going to write SD. There is a symbol, and it's the same as the variance, but then an X next to it, so the standard deviation of your X or your data. And this one is very simple for us to do. Standard deviation equals the square root of whatever you got for your variance. Okay? Also, variance would be your standard deviation squared. So it's this formula, or if they give you standard deviation, it would be standard deviation squared. So standard deviation is the most used measure of dispersion. Okay. They use this in the mean the most often. Range and variance isn't used as much at all. Variance isn't a very good measure of dispersion, doesn't tell us really anything about how spread out your data is. But variance is needed in order to find standard deviation. So standard deviation, if I was to find how tall everyone is in this class and find an average. So let's say the average is 5'6" I would look at how far away each of us is from that average, and that would be your standard deviation. It looks at how far your data is spread out. Okay, so we're going to do some examples so that you're able to do your homework. I'm actually going to go ahead and put it on the next piece of paper because I'm going to need a lot of space to do each of the measurements. Okay, so number 1. I'm going to give you 12 ticket prices for a concert. So here are 12 ticket prices for a concert. So the first, I'm only going to put a $sign near the first one because that gets time-consuming listing it each time. So here we go, 75, 120, 120. Right, the closer you are to the stage, the more expensive the ticket is. 150, 150. 150, 175, 175, 200, 225, 275. Okay, so there's all 12 tickets. So I'm going to go through all the measurements, but I am going to ask that we round to the nearest tenth. Now for review, tenths is that first space after the decimal. So here we go. Part A, I'm going to ask that we find the mean. All right, so we're going to have to add up everything. You will need a calculator for this part, okay? I'm going to go over how I'm going to enter it, right? I'm going to do 75 plus 2 times 120. Why am I doing that? Because there's two 120s. Plus 145, there's only one of them. Plus 3 times 150, plus 2 times 175, plus 200, plus 225, plus 275. Now you don't have to do the little shortcut. If you'd prefer to write if you'd prefer to write 150 3 times, go for it, but that just saves me some time. And I know that there are 12. So I'm going to go ahead and enter it. In my calculator, 75 plus 2 times 120. Remember, you don't need parentheses. You could literally put 75. Get this so it's not a glare. Plus 2 times 120. That's exactly, and you would just keep going. Plus 3 times 150, and so forth. But I already entered it. I got a total of 1,960 divided by 12, and I got 163.3. Notice I rounded to the nearest tenth because it looked like this. So because I'm rounding, this doesn't round it up, so I get 163.3. So there's my mean. All right, let's go over mode. The number that appears most often in this data is $150. Let's go ahead and cover median. They already listed this in order, so remember, start with your fingers on the outside and work your way in. Notice I have two 150s in the middle, so even if I was to add those up and divide by 2, my median is still 150. All right, my range. My range should be the highest price, which was $275, minus the smallest, and I get $200. I'm just going to circle my answers for each. Okay, so I have mean, mode, median, range. So now let's get into the ones that take a little bit more effort. And so we're going to find variance. So here is how you find variance. So you're going to take each piece of data. So for example, the first piece that they listed was 75 minus my mean, which was 160. So I'm using my data and I'm using my mean. Really important measurement, okay? So 163.3, and I'm going to square that difference. And then I'm going to do the next piece of data. Now there are two 120s, so I'm going to do 2 times 120 minus 163.3. You do have to do it for each one, so I can either write it twice or I can put the 2 out here because there are two 120s. All right, plus 145 minus 163.3 squared plus 3 times 150 minus 163.3 squared. And yes, we're going to have to enter all this, but we have calculators, so no whining. Plus, especially because I don't know how many of you have purchased that scientific calculator. So it's not going to help if I show some of you and some of you don't have the ability to do that. So 200 minus 163.3 squared, we're almost done listing these. 225 minus 163.3 squared, and last 275 minus 163.3 squared. Now I'm going to put all of this in brackets because all of this is on the top. Once I find what that sum is, I'm going to divide by 12. Right? So it is going to take a little time. My calculator can only handle so much at once, but I literally put it in parentheses. So here's how you'd enter one of them, and I did 75 minus 163.3 parentheses. And then you should have a squared button on your calculator, okay, or Desmos, but I'm going to hit that squared button, and there we go. And then I would do plus 2 parentheses, 120 minus 163.3 parentheses. Again, it hit the squared button. Now, if you can't find the squared button, you'd use the exponent button to the second. So it's really up to you and your calculator. So I would just continue down the list, then parentheses 145 minus 163.3 parentheses. And I would keep going till I've entered all of it. Okay, and I ended up with, when I did all of this, I ended up with a variance. So 0 variance, there's my symbol for variance, is 2,526.4. Now, the last measurement, standard deviation, is super easy. So standard deviation, SD, is simply our variance, the square root of it. So our variance was 2,526.4. So using my calculator, I'm going to hit the square root button, which is second x squared, so square root. You got to learn your calculator of 2,526.4. And I end up with 50.26. I have 50.26, but since I'm rounding it to the nearest tenth, I look at this number here, and I'm going to round up, so I get 50.3. So there is my standard deviation. Whew, that is a lot, but that is how you find that data. So we're going to do another one just like that to practice. Now remember, you can pause the video, you can fast forward. I'm going to give you the data. Then you try to find all the measurements. Try to find mean and range and variance and standard deviation. So for this next one, I'm going to give you donations, data based on the donations for a fundraiser. And we're not going to do median and mode for this one. We're just going to cover the new pieces of information in this section. So here are the donations. Someone donated 10, 50, 100, 100, 100, 120, 120, 125, 150, 150, 250. And we're going to find the following. We're going to find the mean. We're going to find the range. I'd like us to find variance. And last, we will find standard deviation. Okay? So, if you want to pause the video, try it for one example, and then you can check your work with me. Okay? Just an option. Sorry, I had to drink the coffee. So let's start with mean. So x with the line above it, let's practice writing that symbol. Would be, parentheses, 10 plus 50 plus 3 times 100 plus 2 times 120 plus 125 plus 2 times 150 plus 250, parentheses. And I'm dividing all of this by, count them up, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if you want to pause me, you can. I've already done this, so I know that the mean is, I ended up getting, where's my number? I got 1,275 for the sum on top, divided by 11. I ended up with $115.90. Okay. Range, I'm going to take the highest data, which is 250, minus the lowest, and I get 240. Remember, range is a nice measure of dispersion because it shows us how the data is spread out over $240, right? The highest to lowest has a difference of 240. Variance, right? That's the one that takes forever. So theta squared, did I say theta? It's omega. Whatever. Equals the first piece of data minus our mean squared, right? I'm using that mean. Plus the next piece of data, so 50 minus 115.9 squared. Plus, I'm going to have 3 of these, right? 100 minus 115.9 squared. Plus 2 times 120 minus 115.9 squared. Plus 125 minus 115.9 squared, plus 2 times 150 minus 115.9 squared. What a pain. Can you imagine if you guys all just purchased a scientific calculator? Then it would do this formula for us? What? Okay, I'm going to put brackets. I'm going to do all of this, and then I'm going to divide by 11. Right, because there are 11 pieces of data. So, you can pause me. When I added everything up, I ended up with 36,740.9, and I'm dividing by 11. I ended up with a variance of 3,340.1. So there's my variance. Standard deviation, so theta x equals the square root of what I got for variance. And that equals, if I take the square root, I got 57.8. That means that on average, each piece of data is $57.80 away from the mean. So up here, in the concert ticket prices, my standard deviation represents that each piece of data, on average, is $50 away from the mean. All right, so that's how to calculate everything. I'd like to go over 2 questions of just analyzing, and they're similar to your homework. So number 3, I'm going to give you 2 high schools, North High School and South High School. And I'm going to give you some data, and we're going to talk about whose data is more spread out. So North High School, had a mean of $183 and an S standard deviation of 11. Okay? South High School had a mean of $181 but a standard deviation of 21. So which distribution is more spread out? Okay, so notice their means are very similar. It's their standard deviations that are very different. This standard deviation of 11 means that on average, the data is only 11 units apart. So 183 plus 11 would be 194. Okay, this South High School, the mean's slightly lower, but the standard deviation is much greater. So the average distance away from the mean is 21. So that means that this data is much more spread out because the standard deviation is greater. So I would say, which South High School, because the standard deviation is much greater. Okay, last question for today. A school theater had admission prices of $10, meaning everyone, no matter where you sat in that theater, paid $10. For the show, 876 people paid to enter. So we're going to find the range, the mean, the standard deviation, and then we're going to talk about the standard deviation. So let's start with the range. If every single person paid $10, that means that there is no highest or lowest. Even if I took 10 minus 10, I still just have a range of 0. What about my mean? There's only one ticket price, so everyone paid 10. So even if I added up all the 10s, 876 10s, but I divided by 876, I would have an average of, guess what? 10, because everybody paid the exact same price. Standard deviation. Standard deviation, they all paid the exact same price. So my standard deviation is also 0, because everyone paid the same price. So if you encounter a problem like this on the test or on homework, if the standard deviation is 0, must the data be the same number? Absolutely. Yes. So if you ever encounter, if they tell you there's a standard deviation of 0, it means that the data was all the same number. And that should conclude what you run into in homework. And so hopefully that helps if you guys need it. Again, if you guys end up getting calculators, I can give you the shortcut. Okay? Bye.